So let's talk about our key takeaways from this lesson. I know we did a really complicated function in the previous video and gave some intervals on which the function was continuous, but arguably the nicest thing that we're going to take away from this lesson is that all of our main functions that we're going to be working with, which include polynomial functions, rational functions, radical functions, trig functions, exponential functions, and logarithmic functions. All of these main types of functions that you've learned in Algebra 1 and Algebra 2 are all continuous. So these functions are all continuous across their domains. So we might have to exclude some values that are not in their domain. For example, if I gave you a rational function, we still can't divide by 0, but we can say that that function is continuous everywhere except for where we're getting a denominator of 0. And that's actually a really powerful tool for us moving forward, that we're going to be able to take all of these functions, and when we're working with them, we're going to be able to say this function is continuous. We can also speak and what we kind of focused on in terms of some of the examples in this video, in this lesson, a function is continuous on a closed interval a to b, if and only if it is continuous on the open interval a to b, which again, we get to say that about each of these types of functions. If I give you a function, we're able to already say that it's continuous on this open interval. And if the following statements are true, that the limit as x approaches a from above of f of x is equal to f of a. So again, this left endpoint, we can close it off if we're also approaching the function value from the right. We can actually not worry about what's happening to the left of our interval if we're not looking at what's happening to the left of it. And we apply the same logic to b. The limit as x approaches b from below of f of x is equal to f of b. So as I'm approaching my right endpoint from the left, if it matches the function value, I can close off continuity right there. But the biggest takeaway really is going to be this statement right here, because there's going to be a lot of times in this class where we're going to want to be able to say that this function is continuous over an interval, and we're going to be able to say that for each of these types of functions across their domains.